49-inch Vizio TV. And the actual model number of this TV is a M492i-B2 So it's a 49-inch Vizio. Show you the problem that we're having with this TV. I'm going to plug it in. When it comes on, there should be a white light right here. Okay, and I'm going to hit the power button on the side. And absolutely nothing. When you hit the power, the light should come on right here and it should stay white and then the screen should come up. But we have a totally dead TV. Absolutely nothing. Now this back cover may be a little tricky to get off. Number one, because you would think that the black part and the silver edge down here, going all the way around the TV, is separate, but it's all one piece. This is actually connected. The silver trimming is actually connected to the back cover. I'm sorry, those are the wires for the actual power button, okay? I've already disconnected them. So be very careful when you don't just yank the back cover up after you get all the screws out, because you're gonna either damage the connectors or these go right here into the main board. As you can see, these two wires are going to the power button. Okay, so these wires here, which plug into the main board, are going to the power button, and also our standby light, which is in here, and also this is our infrared detector for our remote control, so we can use the remote. Okay, let's just go over our boards here. Here is our power supply. This here is our LED driver. This uses a separate LED driver board. Okay, so the voltage is produced here on the power supply where these capacitors are. There's a connector. As you can see, the LEDs are actually going down here inside the TV. Okay, this is our TCON board, timing control board. The connector's going right to the panel drivers, connected to the screen, all right? And this is our main board, okay? And see, do we have a Wi-Fi module? Yes, and this here is the Wi-Fi module, connected to the main board. And I believe this just plugs up, unplugs from the main board via this connector right here. All right, and this is our antenna, which is going to the chassis, which is connected to the chassis of the TV at the top. All right, that's our antenna wire. So we're going to center about first, because since this is a dead set, is the actual power supply board. Okay, so there's many ways that you can approach it to eliminate the power supply board, or to figure that, you know, that is it. Is we can check our, find out where the AC is coming in at. This is our AC input right here, going down to the plug, right? Which is the plug here. That's going to the wall, right? Pretty much self-explanatory. Okay, we plug it in at, you know, when the back cover is on, you know, that's where you plug it in at, right? The first thing that I usually normally check on a dead set is I always check the AC fuse. There's always going to be a fuse on every device is located right by the AC input onto the power supply board. Okay, now it may look like this. It may be a soldered in fuse. A little. Let me see if I can get some examples of what you might see. So here are some prime examples of fuses that you may encounter on electronic devices. If you don't see that long glass fuse with the metal end like the ones that was on the TV, you're gonna have what they call these are pico fuses. So you're gonna have something that look like this, right? They almost look like a resistor, but they're actually not. They do have the value located on there as far as the amperage rating. You might say 1.5 amps, 3.3. So these are also pico fuses. You'll commonly find these type of fuses on like T-con boards or other devices. And they also look like surface mount resistors. The surface mount fuses. Okay. And there's another version of a surface mount fuse right here. Okay. And you're also going to have these type of fuses. These are also fuses. Now these fuses you'll commonly find on smaller televisions at the AC input, okay, instead of the long glass fuse. All right, and so you'll actually have to turn, over the board on the other side to check it. Okay, these are also very common fuses. They may be different colors, but they are going to be looking like this. They're all shaped like that. And as you can see, but there's the amperage rating is going to be 3.5 amps, 5 amps, 1.5, whatever on top. And they look like little, almost capacitors. And like I said, they'll be flush mounted into the board. They won't be sticking up, so you cannot check these on top of the board. You're actually going to have to take the board out and turn it around and check the leads on the bottom and see if it's open or not. All right, and you can get these fuse kits, on eBay or Amazon. A warning, make sure your device, when you're checking the AC fuse or any fuse, is unplugged, okay? Just warning, okay? Make sure it's unplugged. There's no voltage going through there because we're just checking resistance. So I can go here, I'm gonna go to the fuse one side, and that fuse is good. If you want, depending on your meter, you can just go to the beat mode. This meter is actually stupid, kind of complicated. Go to beeper. Okay, and we know that is a short or a good fuse. So a good fuse is always reading short. So that means that current can go through it. So the fuse is good. And you can, if the fuse is blown, just go ahead and replace it with the same value and see what happens. If it blows out again, that means that you have a short. My fuse is good, and I am going to go to the plug coming from connected to the power supply that is going to the main board. Now this one is going to the main board. Okay, and one of these pins should have the standby voltage on there, 5 volt standby. Just change that to DC volts, and then checking voltage, we do have to plug in our power cord. Okay, eventually the TV's plugged into the wall. A connector going to the main board may have a legend next to it. And this one actually does. And we should have our standby voltage. As we can see, it is actually marked 5 VSP. That's after 5 volt standby. That is the voltage you should have whether the TV is on or off. As long as it's plugged into the wall or plugged in to the power, we should have 5 volts. And that's what they call a standby, because it's standing by waiting for you to turn on the TV. Okay, so the main board actually turns on the rest of the TV. If it does not have a legend on the connector or plug, just don't worry about it. Just check all of these wires, all of the pins. Okay, if you don't have any voltage on either one of the pins, double check it again. So it's pretty easy. If you have standby voltage on a dead set, if you do have it, okay, the standby voltage, then you have a main board problem. Okay, point blank, just change the main board. All right, if you don't, then most likely it's a power supply board problem. On all power supply boards, there is a line, as you can see right here, it goes around up there to there. All right, and that is separating the secondary side from the primary. The hot side, the primary side is not connected to the secondary side. Okay, they just use transformers, all right? If you want to know more detailed stuff about it, just make sure you check out my course, The Art of Troubleshooting and Repairing Modern Televisions. It explains that fully. Hey guys, if you already work on televisions or other electronics and want to learn more about television repair, make sure you check out The Art of Troubleshooting and Repairing Modern Televisions. This is an intense, detailed, easy to understand, online television repair course designed to show you how TVs work by covering important circuits and sub-circuits. You are not going to find anything like this online, especially in the English language. Students also have an online community where they can post videos, pictures, and ask questions about TV repair. The entire course is step-by-step instructions covering every circuit from the power cord to the power button in that order. And that, my friends, is the art. Knowing how the television works from start to finish. All the trainings include live PowerPoint presentations showing you in detail how all the circuits work, and also live hands-on trainings putting you right there in the action. This entire course is expected to be completed by midsummer, but you do have access now for a special pre-launch price, and it presently includes over 8 hours of intense, detailed, easy to understand trainings. And my name is Robert. I've been working on television for 30 years, and I wish I would have had a course like this about 10 years ago. That would have absolutely shortened my learning curve. If you want to see a 15-minute demo demonstration of the course, just go to my channel, Big Dog 8882, and check out the TV repair course update and live course footage. And that has over 15 minutes of raw footage from inside the course. So guys, what are you waiting on? Click the link below or in the video somewhere, and I will see you in the course. Big Dog out. I can ground my negative lead on my meter anywhere on the metal chassis on the power supply. All right, I can even go here to the screw and put my black lead and ground my lead there. And I can just ground it right here on this metal plate, okay? Okay, make sure it's out of the way, not touching anything. All right, I'm gonna go ahead and plug it in. Let's start, and I just want to check all the pins anyway. There's nothing there. Nothing on that one, which is labeled standby. And it's best to go on this side instead of actually going to the actual pins, because you might accidentally short out something if you are getting voltage there. Okay, I don't have anything on that one. Nothing here. Nothing there. Nothing there. Nothing there. Need to double check, make sure I had that pushed all the way in. I think these leads a little bit. Okay, nothing there. Nothing there. And just to make sure, I'm actually going to follow this wire right here, and that is going all the way to the main board, like I said. And I'm actually just going to unplug it to make sure there's nothing shorted on the main board that is drawing down the standby voltage. Once again, just double check it. 0 volts, 0 volts, 0 volts, nothing, nothing, nothing. No standby voltage at all. So I'm just going to start checking some other stuff on the secondary side. Okay, now these are diodes, I believe, right here. All right, so nothing there on the cathode of the diode. Nothing here. I'm going to look at the positive side of my capacitors. Nothing. Nothing. And do I have anything else? I got some inductors. I have nothing. I have absolutely no voltage on the secondary side of my power supply, which means that we definitely have a bad power supply. Now, just to make sure that nothing in the AC line is open, like one of these inductors, right, which actually filters out the AC before it's being converted to DC by the rectifier, what I'm going to do is I'm actually going to, and be very careful when you're doing this, because if you cross the leads up or short something else, you will damage the power supply and it'll get a serious shock. So the TV is still plugged in. I'm going to go to the main filter capacitor. Going to be your biggest capacitor on your primary side, you know, close to where the AC line is. This one uses one, is laying down. Some may use two. As you can see, here is our AC input plug. All right, our fuse right there, like I just talked about. We'll have our line filters or inductors, which I say sometimes can open up. But as you can see, we're still on the primary side. Here is our line separating our hot / primary. They also call this hot side. Okay, to the secondary side, which is over here, and this is the part that's going, the plug is right here, is going to the main board. All right, and as you can see, we have two big filter capacitors. Okay, and as you can see, the voltage rating is about 450 volts. They are going to have a 300 or higher voltage rating. All right, and that is the DC voltage that you're going to have after it comes out of the bridge rectifier, which is located right here, up under these 4 pins, up right here up under the heatsink. And just show you what that looks like, right here, it is just bent over up under the heatsink to keep it cooler. All right, and so that's what would be right there up under the heatsink. Okay, none of these pins should be shorted with one another. And see if I have voltage there on this capacitor. Because if I do, that means everything in the AC circuit is fine. Our problem is either going to be most likely somewhere else on the primary side. So, being very careful not to short the leads together. Take one lead. You can take your negative lead and put it on negative. Okay, on the negative part, there's a lead coming out. Put it on a negative lead on the capacitor. I'm going to take this one, be very careful not to touch anything, and put it on the positive side. And if you look at my meter, I have 168 volts DC. And it is not even fluctuating. Can you see that, hopefully? 168.45 volts. Let me unplug it. And even after you unplug it, still do not touch this over here, anything over here with your hands, or we take the board out, lift it up, and all that kind of stuff with your hands, because the capacitor still has a charge on it. Positive, negative. We still have 136 volts on there, and you can see it is discharging. The voltage is going down. That there is a problem here. Look at that. That is a MOSFET, right? It's actually a all-in-one MOSFET that has the driver and MOSFET built into one IC. All right. Most TVs use actual three-legged, transistor-like looking like MOSFETs, but this one uses a smaller one because I guess this TV consumes less power, or it consumes less power pretty much, the power supply board. So all they have to do is use that one, which was obviously didn't hold up. Well, I guess it did hold up, but it eventually shorted out or blew up. Okay, so that is a serious problem. That is why we are not getting any standby voltage. Is that this capacitor, okay, eventually is going across 2 windings on this little transformer. So it's coming in one winding, and the other winding, okay, which are both connected. These should be 2 separate windings. All right, the one here and the 2 down here, however it's configured. And the other end of the winding on the other side is coming out of the transformer, is always going to the MOSFET. And what the MOSFET does, it takes that 168 volts, and it switches it on and off about 50,000 times per second, or at 50 kilohertz. All right, and what that does is create energy inside the transformer, and it transfers the energy to the other winding on the secondary side, on this side, okay? And that is then, that energy is being rectified, or produces voltage after it's rectified by, I'm guessing, this dial right here, and then we should have like 5 volts or whatever. So, but anyway, let's just double check that. So we're on hot ground still, so we're gonna have to use the negative portion of this capacitor, which is linked to hot ground. So what I'm gonna do is, to be on the safe side, I'm actually going to be very carefully, okay, while it's unplugged, I'm going to put my alligator clip right there on the negative side, okay, which is hot ground. I'm actually gonna plug in the TV, just plug it in, and I'm actually gonna go to one side right here of this MOSFET, which I have our same 168 volts there. And there it is, 168 volts. And this also should be 168 volts. Okay, which is going across. There it is. Oops, yeah, I almost slipped up. 168 volts going across this transformer. And this is the other side here, maybe. Let me see. Okay. Yeah, so it's actually, so these two windings in the middle of the transformer, out of the 4, are actually what's going to the MOSFET. Okay. So let's just see if we're going to get any switching. The MOSFET is not switching. Like I said, this MOSFET uses a all-in-one driver and MOSFET, with the MOSFET driver built into one IC. So I've got my positive lead on pins 7 and 8. Those are the ones, there is the actual drain. Okay, I'm trying to say, yeah, that's the drain pin, okay. And the gate pin, which is located internally, and the source pin obviously would go to ground. So, and I have my negative lead for my probe on the negative side of the filter capacitor once again, since we are still on the hot side. The voltage from the big filter capacitor is going through one of these windings, the 2 middle windings. It's going in probably through this one and coming out through this one, and that is connected to the drain pin. All right, where we got my oscilloscope lead at. Now you might say, what are the other 2 pins for? The other 2 pins on this transformer, which will be the outside pins on this particular one, are for the VCC voltage that is going to this IC to make it work. Okay, so that usually goes through a diode, a resistor, and a electrolytic capacitors, which are probably one of these 2 here. Okay, so what happens is, when the TV is first turned on or plugged in, it is going to start up the IC, or like a soft start, and once it starts up, then these other windings will send the VCC voltage to the IC. So, well, let's maybe I can just show it to you better than I can. So, what I'm going to do is, I'm actually going to, the TV is unplugged now. I'm going to plug it in. Okay, watch when I plug it in. What's going to happen? You see how it went up like that? Okay, so it's trying to start up, but obviously there's no VCC voltage because the IC is damaged. So yeah, unplug it, and you're gonna see that big startup right there. So there's no drive circuit, because drive circuit does not look like that. And as you can see, we have approximately 50 kilohertz or whatever. We have 0 hertz. Okay, now obviously the IC is blown where the part number is located at. That MOSFET slash driver IC is blown. I found the number to the power supply board, and as you can see right there, it says DPS-146EP and DPS-167DP, and this one is obviously marked with the circle, and the square is obviously marked. So this is the DPS-146EP space A. Okay, obviously it stands for digital power supply, I'm guessing. Something power supply. So basically they use the same board, okay, for the same board. When I say board, I mean board without the components for a different TV. And they just add different components on there, or extra components on there, probably for the 167 for a higher power television, maybe. I actually found a repair kit. So this obviously is some type of common problem. And okay, as you can see, it includes everything. I'll leave the link to this in the video in the description. So we have our MOSFET right here, which is IC 901. So we got the regular diode, a Zener diode right here, a resistor, our blown MOSFET controller, and this is our PC 801, looks like, optocoupler. Okay, so what I do is actually got the part number off the IC, off the new IC, because you kind of like want to see what's going on before you want to start replacing all these parts. It's pretty good to do that. Of course, you can't see it on camera, but the part number is a LD7913JGM6. Okay, so I'm gonna get the data sheet off the IC, for the IC. So just go to Google, LD 7913, and it should come right up, 7913, and here it is right here. Okay, as you can see, JGM6 data sheet. And we usually go with the first one. Data sheet 360. And it says 79 switching regulator controller. Okay. So CPDF document, I hit that. And there it is. Blow this up a little bit. Okay. So here's the actual IC in a circuit. Not this circuit. This is not the schematic for this power supply board, but it shows you how it works. Now, like I said before, here's the drain pin, okay, which is coming off of the transformer. And as you can see, the one winding of the transformer, of this transformer that they're using, and as you can see, the other end is going right to the physical capacitor. All right, so we have our rectified voltage off of this rectifier diode, the 4-pin bridge rectifier diode, capacitor, and this is what they call a snubber circuit. It's not important. It's just to protect it, protect the IC from surges, which we will check. It usually consists of a capacitor, a diode, and a resistor. All right, and these are the two drain pins, pins 7 and 8. Okay, and it's going into the drain pin. And here is our VCC, and here is another winding off of the same transformer. Okay, the other winding, and we have our diode and our capacitor. So, if we go down further, we'll actually see here's the pin out. So pins 7 and 8 are connected. Those are the drain pins. The VCC pin is pin 5, and our source pin 1, which is usually going through a low ohm resistor and going to ground, just like on the regular MOSFET. A regular MOSFET source pin have ground, and our comparison, which is probably going to the optocoupler that they gave us. Okay, so here's some important things that, this explains all of the pins. VCC is power supply to VCC. Our source pin, which is labeled S, ground, drain terminal, MOSFET, and here is the inside of the actual MOSFET. Here is the driver stage, which will normally be the gate pin. Okay, so this is the actual MOSFET inside of the IC right here. And then you see that's drain, and this is S, that's source. And you see the gate pin is automatically being driven with an internal driver on that particular MOSFET slash controller IC. All right. Just getting in the way, okay? And here's some stuff that I want to point out. Okay, so this here we have our supply voltage for VCC, which should be between 11 and 25 volts, okay? And our VCC capacitor is between 10 and 42 microfarads. So if you have the capacitor is blowing up or something, you can try, you know, a 22 microfarad, 47 or 10. So it doesn't matter. And if we go down some more, to drive these two MOSFETs right here, let's just say these are the MOSFETs that are driving the transformer, which are probably correct. Then if we look on, because we're on the hot side, okay, there's our power plug, there's our fuse. If we look on the back, up under here, okay, this is the MOSFETs right here, okay, right over here. This is the actual driver IC, okay, and that's what cuts the MOSFETs on and off, thus cutting the 168 volts or 388 volts on and off. Okay, so the one that we have on our board today has that all built in one, the MOSFET with the driver IC. Switching frequency should be approximately 100 kilohertz. And this package is known as a DIP7. All right, even though it's labeled 8 pins, pin 6 is missing, so we just only have 7 pins. So our VCC line, there's always a capacitor, electrolytic capacitor, as you can see, and a diode. Now, a very good thing to check on a lot of failed power supply boards, if you're getting the same problem, and especially if they're using MOSFETs, is you always want to check the controller IC or the driver ICs. Pull up the data sheet. They're only gonna be like a couple small electrolytic capacitors anyway, and check that electrolytic VCC capacitor for the driver circuit or for the driver IC for the VCC pin, because I can almost guarantee about 10 to 20% of the times that capacitor is failed. That could be the start of a problem, because a shorted electrolytic capacitor right here can not only blow up the chip, it can blow up the chip and some other, it can short the diode out, whatever, right? Here's a built-in 700 volt power MOSFET, okay? And both your startup circuit is built in. Like I just showed you, switching frequency is about 100 kilohertz. That may change, depending on the load that we have. Put our positive side, and okay, and that's also coming around back to the drain pin. That's any switching MOSFET on a power supply board like this one. All right, you should always have continuity from the positive side of the capacitor through the transformer and back to the drain pin of the MOSFET, whether it's using this kind of MOSFET or a regular 3-pin power MOSFET. The VCC pin on here is pin number 5, okay? Number 6 is missing. So that should be going to the cathode, this pin right here. Number 6 is missing, 5, 6, 7, 8. 1, 2, 3, 4. Okay. All right, pin 1 is the source. So let's check the VCC diode. It should be going right to the anode of, so put my meter here on the VCC pin. It should be going to the, the cathode of one of these diodes. Right there. Okay. Let's check that diode. That is shorted. The diode is shorted. It's reading short anyway, okay? Now the source pin is pin 1 right here. That's usually going through a low value resistor. So I'm going to put my lead there on pin 1. Hopefully you can see that. Pin 1 right here. Right there. Let's do it this way. That's pin 1. Right there. So let me just switch hands so I can... That should be going to one of these resistors. That's actually going to this diode right here. The Zener diode up under this heatsink. You can't see it. Let's see if that's shorted. That is reading short. Okay. ZD903. So this power supply is probably made a little bit differently. Yeah, so that is, yeah, that's the Zener diode. And that looks like ZD909. Let's see if that's the one of these in the package. With the Zener diode. And there it is. ZD909. Okay, so there's 3 components that we need to replace. And this resistor here is R915. So let's see if we can find that. Okay, here is R915, and you see how it looks. It's actually a fusible resistor, okay, for safety purposes. And I'm gonna just go across it. It should be a, I'm assuming it's a low ohm. I'm sorry, it is 4.7. Okay, and I'm reading 4.7. Let's go here again. If I want to put it in just regular, without the beep, just ohm reading, 4.68. So that's a 4.7 ohm resistor. And I did check the new one, and it is 4.7. All right. So don't have to change that. You can if you want to. But I'm also going to check and find out which one of these diodes is, I'm sorry, which one of these electrolytic capacitors is for the BCC circuit, because that would be a shame if they gave you this entire, if you put in this, if you bought the kit and put in the entire kit, and guess what? It blew the IC up again because the capacitor was shorted, right? Okay, so let's just double check. Okay, pin 4 is the comparator pin. That is going to the optocoupler. The optocoupler is going to provide feedback to let the IC know how to switch, right? And what duty cycle to switch at. All right, depending on the load. Okay, so here is pin 4, and that should be going to one of these optocouplers, which is probably the same optocoupler that right there. Okay, and if I double check, that's the second one from the bottom. If I double check that, it's probably going to be PC902, and this one is PC601. Which is way at the top. So my concern is, why would they tell us to switch that one? But I did check the resistance on those, and those seem to be fine, as long as they are not shorted. At 601, that is on top. That looks like that is for the LED circuit. Why they want us to change that one, I don't know. Someone put this in diode scale. And we should be getting a diode like reading. One way should be open, the other way should be 0.6 voltage drop. Okay, and the other way is open, so that's good. All right, let me check these other ones down here. It's 0.7 voltage drop across that. 0.6 across that one. Okay. 0.6. 0.7. 1.2 voltage drop one way, and 2.8 that away. So far we have put it in beat mode. We have a shorted VCC diode, which is obviously going to pin 5, right, on the IC. Okay, with a shorted Zener diode on this side, that's reading short. I don't see any open resistors. Resistor, once again, is 4.7. So we're going to end up changing these 3 parts, and we're also going to check the capacitor, the VCC capacitor. We'll just check both of these for the IC. Okay, so let's just disconnect the board. First, we have to pull this out to the main board. Pull that out. And then obviously once we get the screws loose, we're going to have to pull the whole board out from this connector right here. And I'm also going to check the solder connections on it. Four screws. Lift up and it slides right out. Okay, what I noticed is that I've already pulled off the IC right here, and when I go back to this diode, it is reading just fine, and the diode that they gave us is actually this diode here, and I'm looking at it and it says D95950B or 958. That is actually the diode over here on the secondary side, on the cold side, the standby diode. Alright, and that is shorted. Okay? So we're going to remove that. They give you some pretty good instructions on here. It just says, what it's saying is, now it says, I'm reading instructions, right? It says just cut the old diode out, and there is an empty spot right below it, connected right in parallel to it, where you can place the new diode at. And I'm looking, and yes, there's actually right here an empty spot right there, which is connected to the diode. Okay. And it actually shows you which way to put the cathode of the diode. And ooh, look at that. There's already room for it. And I'm going to take my new diode. Where are we at? Right here. This is the cathode side with the line, cathode side with the line on the diode. Put it in there. There's a ferrite bead on here, but I'm not going to put that on. I'm just going to do exactly what it says. I'm going to put it in. And don't forget to cut the leads. Alright. Black on the cathode. Yep, 0.3 volts one way. And should be going almost infinite reverse the leads. And that's obviously a capacitor charging up. Okay. Now the only thing we have to replace is the IC and the Zener dial, which is also reading short. I'm going to take that out. What we thought was bad, that is reading good. Okay? And so is this dial. Okay, this dial over here, this other dial is going to the VCC. Now, I'm going to go ahead and pull out the Zener dial, and that's ZD909, which we have here, ZD909. Okay, it's out of the circuit, and as you can see, that is short. Meters in dial mode. Yes, that is shorted. Alright, so let's replace that and the IC, and we should be in good shape. Okay, here's our new diode, new Zener diode here. Okay, let's go black to cathode, the stripe side, and that is good. 0.7 volt voltage drop across it. Alright, the other way should be infinite. Okay. It is marked on the board, the cathode side with the little line on the symbol. I'm going to put that in there. Double checking, make sure it is correct. Okay. Make sure there's no short across the trace. We still have a short across the trace. I haven't put my IC in just yet. You are going to read a short across the Zener diode because if you look, there is some resistors in between both pins running parallel, and one of them, it looks like a 4.7 ohms. So here's a diode in red right across there, here and here, and one of these resistors is a 47 and the other one looks like 3R something, so 3.6. Alright, so we're getting about 2.2 ohms, so let's not worry about that right now. Let's go ahead and put in the actual MOSFET. I'm going to have to put these pins a little bit closer. Okay, that lined up. That lined up perfectly. I'm going to hold it in there with my finger while I turn it around and just kind of bend some of the pins outward, like the ones on the end, so I can hold it in place. One, two, three on one side, and 4 pins on the other side. Making sure you don't have any solder shorts in between the pins. Okay. What I like to do is actually run a small flathead screwdriver in between the traces just to make sure. Just make sure that it's not touching each other. Looks good. Okay. Everything's soldered in. Now, what I want to do is I want to check those capacitors, because that one capacitor for the VCC line was reading short until I pulled the IC out. So yeah, y'all want to check these right here. This brown one, the one on top, that's 10 microfarads. That is the capacitor for the VCC for this IC. And this other one, capacitor through this other diode, is actually the VCC for this chip right here. Okay, which is driving these two MOSFETs, okay, which are driving this transformer here. So let's just check that. Since our dial was not shorted, our VCC dial is probably okay. But let me just go ahead and check that. Should be getting 10 mics. 1103, good enough. And this other one is 22 mics. 22 microfarads. Excellent. So I believe we are done. Okay, let me double check these diodes. Make sure. We've got some more Zener diodes down here. Let me just make sure those are okay. Good. 0.6. 0.6. It's backwards. 0.6. 0.6. VCC diode here. Okay, and the VCC diode for this chip is right here. Okay, and those are good. Here's another diode right here. That's good. The resistor is still good. The resistor should be reading low as 4.7 ohms. If you want to double check it, I'm just going to go to ohms, and it should be about 4.7. Yeah, 4.7 ohms. Okay. Actually, this standby dial is a Schottky dial. That's why we're only getting 0.3 volt with its forward bias, a 0.3 volt voltage drop across it. So that's a Schottky dial, but it should be infinite the other way still. Okay. Now, if it was reading 0.3 both ways, then we have a problem with the dial. So everything seems good so far. Okay, so let's just, everything's plugged in. Alright, to show you what I'm talking about. I do have my scope hooked up on the drain pin, pin 8, last one. You can see that or not. But anyway, I got my negative lead on the negative side of the big bulk capacitor. So what I'm going to do, get a zoom close up on that screen, is I'm going to plug it in, and without me returning the power on, in order for us to get the standby voltage, we have to, this transformer has to be switching on and off via the MOSFET. There we go, and that is our drive signal. And let's do auto set. we go. And right now we are at 20 kilohertz. Okay, like see right here it says 24. It's switching back and forth. And the TV isn't powered on yet because I got to plug it in and plug the back cover in for the power. But so that is actually working. And you can also check that on your meter if your meter has a good frequency tester. So that's it. So it is switching, it is working, and we'll actually power it on so you can see, hopefully, that the TV comes on. Okay, so this album, make sure everything's plugged in. Main board's plugged in. Everything's plugged in. And one of these, I'm gonna just plug this back in right fast. One of these is standby light, and the other one, which is probably the 2 wires, and the other wire is for the power button. Standby light, remote sensor, power button. I'll go for those, and then go ahead, place it back on there. I'm actually just going to put in a couple of screws because if it works, then I mean, no need to take the cover back off, right? I'm going to put in 2 screws for now so it won't slip out of my hand. Okay, I'm going to hit the power. So you get a solid white light. And there we go. And as you can see on the bottom there, so it looks like we are definitely in good shape. All right, guys, that's it. I'm gonna go ahead and pack it up, and we are done. So if you like the video, make sure you give me a thumbs up. And if you want more videos like this, make sure you do subscribe, hit the notification bell so you won't miss any videos. You'll be notified as soon as I upload one to YouTube. And guys, please, if you want to learn more about these power supply stuff, I do have a very excellent power supply course. I'll leave the link in the description. Okay, but until then, guys, I will see you guys in the next one. Big Dog out.